Hi guys, welcome back to Chemistry 24x7 series. In this series, we have been exploring solution for previous year's competitive exam papers. If you are new to this channel, don't forget to subscribe and hit the bell icon for notifications. Let's dive into today's problem. Today, we will tackle a question from University of Hyderabad PhD Entrance Exam 2019 exam question. According to this question, this substrate initially react with LDA, which then react with diphenyl selenide, which provide intermediate. That intermediate once again react with LDA and followed by methyl iodide, and next step which react with hydrogen peroxide that produce one product. So here you see there are four options. Let's find out together which one is the correct option for this question. The first step of the reaction involves LDA. We have already discussed LDA in our previous videos. If you missed to watch, don't worry, you can find the link from our description box. So LDA or lithium diisopropyl amide is a non-nucleophilic sterically hindered strong base that readily abstract the proton from acidic position in a molecule. So generally LDA is useful for the generation of enolate ion by abstracting the proton from less hindered sites. So this is one of the example for using LDA to generate the enolate ion and their further transformation. So additionally, LDA can be used to abstract the proton from benzylic position and even acidic proton on aromatic ring also. So now you come to the our substrate. When you use LDA, which readily abstract this acidic one of the acidic proton, resulting that generation of corresponding enolate ion. After the generation of enolate ion, which readily react with the diphenyl selenide, here you see how this happened. This electron shifted here, then followed by this electron attack one of the selenium atom, resulting that cleavage of selenium-selenium bond to provide this corresponding intermediate. Here we should note that stereochemistry of this intermediate. So before that, you just you see the stereochemistry of this enolate ion. So here you see the bottom phase is only occupied by two hydrogen atoms, while in the top phase is highly sterically crowded with these alkyl groups. Therefore, this particular reaction takes place by bottom phase, resulting that generation of this particular intermediate. The next step is again reaction with LDA. So here you see this intermediate has one more acidic proton when you use LDA, which readily abstract this acidic proton, resulting that generation of this corresponding enolate ion. So once you generate this enolate ion, here you see the stereochemistry of this phenyl selenium species lost, so resulting that generation of this enolate ion. So the next step, which involving the reaction with methyl iodide, once again here you see this enolate ion stereochemistry. The bottom phase is less sterically crowded when compared to the top phase. Therefore, the methyl iodide also approach this enolate ion by bottom phase. So resulting that here you see how this happened. So this electron shifted here, then this electron attacks this methyl carbon and followed by kick of I minus to produce this corresponding intermediate. So moving on, our next reaction condition is reaction with hydrogen peroxide. So before that, you just look our intermediate. So our intermediate selenium has two lone pair of electrons. Therefore, when you treat with hydrogen peroxide, so here you see the selenium atom attack one of the hydroxy group. Since this oxygen-oxygen bond is weak, we already know that. So the selenium attack one of the oxygen, resulting that kick off OH minus ion to produce this corresponding intermediate. So now you see selenium get positive charge. So now you see next step, the hydroxide ion readily abstract this proton, resulting that generate corresponding selenoxide species. The next step of the reaction will be selenoxide elimination. So according to this reaction, we need beta hydrogen atom that should present at the same phase of selenoxide. Then only this reaction proceed successfully. Let's come to the our substrate. So here you see selenoxide attached with alpha carbon. So this one is a beta carbon having 3 hydrogen atom, while this beta carbon having 1 hydrogen atom. So however, this hydrogen atom present at bottom phase while our Selenoxide present at the top phase. Therefore, removal of this hydrogen atom is impossible, while when you come to the beta carbon of this methyl group having 3 proton atoms, at least one of the hydrogen atom present at the top phase in order to proceed the Selenoxide elimination. For our convenience, we can redraw this structure. Now you see, so definitely one of the hydrogen atom present at the same phase of our Selenoxide. So now you see how this happened. So this pi electron readily abstract this proton, then followed by this electron shifted here. Now this electron shifted towards the selenium atom, resulting that generate corresponding alkene by Syn elimination process. So based on our discussion, we can ruled out the option A, B, and D. Our correct option for this question is answer C. That's it for today's problem. If you enjoyed this video, please give it a thumbs up and share it with your friends. Don't forget to subscribe and click the bell icon to stay updated with our latest videos, and leave a comment if you have any questions. And thanks for watching Chemistry 24 into 7, which never sleeps. Bye bye.